Hello everybody, this is Iftikhar Ahmed and you're watching our channel Physics by Iftikhar. So today I will be talking about what kind of charges do we have in nature. Whether we have two kind of charges, whether we have just a single kind of charge, or whether we have three kind of charge. So let's find out today what kind of charges we have in nature. Okay, so in the previous class we have discussed about how we discovered the charge, how we got to know that there is a thing called charge exists in this universe. So you see, we are dealing with the theory called electromagnetic theory. This electromagnetic theory, the electromagnetic theory is having basically two parts, two main parts of it. The first part deals with the charges which are at rest. The study of rest charge particles comes under electrostatics. Electrostatic means what? The velocity of the charge is zero. These are the rest particles, rest charge particles having charge q. We will study about these charges, and that study comes under the study of electrostatics. It is a part of electromagnetic theory, and the other part is electrodynamics. This electrodynamics, by name itself, you can see that we are talking about moving particles. The charges which are in motion, if we study the charges which are in motion, that study comes under electrodynamics. So the charges are not at rest. These charges are having some kind of velocity, not at rest, and the charges in motion will also produce magnetic field. When the charges at rest, they will just produce electric field. The magnetic field will be zero, but here we'll get both electric and magnetic field. And when the charges are in motion, we'll get both the field, both electric and magnetic, electric charge and fields. In that electric charge and fields, we have seen the basic introduction in the first class. Now we will see what kind of charges do we have in nature. In the previous class we did 3 or 4 experiments, and with the help of that experiment using electron, proton and neutron, we found out that electron and protons are having some charge, and because of the charge they are repelling each other. And neutron does not have any charge, that's why it is not showing any kind of repulsive force, but the neutrons only having the gravitational attraction between them, and that represents that the neutron does not have any charge. And now let's find out what kind of charges do we have in nature. So the first thing was already cleared about the charges is that when you have two electrons, the distance between them is 1 centimeter. The force of repulsion between them was 2.3 into 10 power minus 24, and the same amount of force was present, the equal amount of force in proton system. So here I have two protons 1 centimeter apart. They will also repel each other with the force 2.3 into 10 power minus 24 newtons. So by seeing these two figures, we can have an idea that we can guess that the charge, whatever the charge is there in the electron, the same amount of charge will be there in the proton also. If the charges are more, the force will be more. If the charge is less, the force will be less. If you're getting this amount of force for this particular charge and you're getting the same amount of force here, it means this charge has to be equal to this charge. So with this experiment, we can conclude that the charge of electron is having the same magnitude as that of the proton. Okay, now let's see what will happen if I take one proton 1 centimeter apart with one electron. So here's I have electron and here's I have a proton. So in this experiment, what experimentally we have observed is these two charges, the proton and these two particles, proton and electron, are attracting each other with the force 2.3 into 10 power minus 24 newtons. As of now, we knew that the charges, if the particles are having charges, they will repel each other. Now we got to know one new property about charge, that they will repel also, not just attract. So this is how we slowly understand the nature. So the property of charge, we are slowly understanding step by step. We are unlocking its secrets. So the first was, we thought that the charges will just repel each other, but now with the help of this experiment using proton and electron, we got to know that the charges will also attract. The charge can also attract each other. So it means that the electrostatic force, the electric force, is not just repulsive, it can also be attractive in nature. Now we can observe one more thing, that the attractive force between electron and proton is same as the repulsive force between two electrons and two protons. If you have electron with the other electron, it will repel it. But if you have electron with proton, it will attract each other with the same force. The repulsive force was this one and the attractive force is this one. They have the same magnitude. It means that the charges present in both electron and protons have the same strength, same amount. The charge on electron is same as the charge on proton, but having different nature. But the strength, whatever the electron is having, the amount of charge is same as the amount of charge present in proton. But there is a difference. What is that difference? The nature of charge is different. If you take two electrons, they will repel each other. If you take one electron with another proton, they will attract each other. What you can conclude with this is that the charges are having the amount of charge is same, but they are of different nature. So by convention, we call electron as, this is just by convention, orbitally we have taken electron as negative charge and proton as positive charge. Okay, it does not mean that electron is having less charge as compared to proton. They both are having equal amount of charge, but because of having different charge nature, we are orbitally calling one as negative and the other as positive. Are you getting my point? So it turns out that in nature we have two kinds of charges, positive charge and negative charge. Okay. See one more interesting fact about charge. Friction can cause charge. Now let's see how friction can cause charge on a body. Suppose I have a glass rod. If you rub a glass rod with silk, the glass charge will get positive charge on it. Due to the friction, we can cause charge on a glass rod. To find out whether we have created charge on the rod by rubbing it, let's put a balloon. This balloon is having helium gas in it. Helium gas will have free electrons in it, free electrons and helium atoms, because it's a conducting gas. Okay, now, so because if you take this rod, glass rod, and move near to the balloon, instantaneously whatever there is a negative charge inside the balloon, all the negative charge will come to this side of the balloon, and all the positive charge inside the balloon will move to this side. Okay, now why this process, this polarization is happening? This process of separation of negative charge and positive charge is called polarization or induction process. So this is happening because the rod is now having positive charge on it. Because of this positive charge, all the negative charges present in the balloon are trying to move near to the negative charge. Just now we have seen there are two kinds of polarities. One is positive and the other is negative. Positive and negative polarities will attract each other. That's why these electrons, these negative charges present in the balloon are moving to this side. The process of polarization is done once all the charges are at one side, at this side of the balloon. The balloon will try to move towards the rod. Why the balloon is moving towards the rod? Because the rod is having positive charge in it. So that's how you can prove that by friction you can cause electric charge. So that's why the balloon is coming near to it. Why? Because the rod is having charge. Rod is having charge, and this attraction is because of the negative and positive charge. At the same time, you will be these two same polarities are having longer distance between them, so that's why the attractive force will be more as compared to the repulsive force. That's why the balloon will come near to the rod. So this is how you can prove you can cause charges. Now let's see one more peculiar and interesting property of charge, that is the quantization of charge. The charge in this universe is quantized. Charge is quantized. What is the meaning of quantization of charge? The charge of an electron or the charge of the proton is, if you're talking about the charge of the proton, you have to take the plus sign. If you're talking about the charge of the electron, you have to take minus sign. It is 1.6 into 10 power minus 19 coulomb. Coulomb is the unit, the SI unit of charge. We measure charge in coulombs. What is 1 coulomb? Now the question is, how much is 1 coulomb charge? Suppose I have a wire. In this wire, 1 ampere current is flowing. Okay, so 1 coulomb charge is the amount of charge flowing through a wire in 1 second. If 1 ampere current is passing through the wire, that is how you define 1 coulomb of charge. That much it is. In a second, millions of electrons will cross from one point to another point. So that many electron, the charges of, if you add all the charges of the electron, you will get 1 coulomb of charge. Okay, so this is the charge of electron and proton. If you are doing for electron, you have to take this minus sign, and if you are doing for proton, you have to take the plus sign. Now let's see the quantization. So in this universe, the smallest amount of charge that you can have is the charge of either proton or the charge of electron. That is the smallest. You can't have charge of a body less than the charge of electron or the less than the charge of proton. Any body in this universe who is having charge, that charge, the charge of that body is going to be integer multiple of this number. If it is having some positive charge, then it is going to be multiple of E with positive number. If a body is having negative charge in it, that charge is going to be integer multiple of E with this negative sign. Now let's try to get the feeling of quantization of charge, how it is. Suppose I have an object, it is having some charge, okay? It is having some positive charge in it, and it is also having some negative charge in it. So the positive charge inside the object is due to proton, we know that. So let us suppose that it is having n1 number of protons and n2 number of electrons in this object. So the charge present in the object is going to be the charge. So the charge of the proton, E plus, will be the charge of the proton. E plus multiply with how many number of protons are there in it, plus N2 with charge of, will give you N1 minus N2 E. If suppose in this object the number of protons is more as compared to the number of electrons, then as a whole the net charge of the body is going to be some positive number. If the charges present in this body, the electrons are more and the protons are less, then the net charge will be a negative number. Any body you pick, if that body is having some charge, that charge is going to be the integer multiple of small e only. That is called quantization of charge. Now let's see an example. The alpha particle. The alpha particle is the helium nuclei. It will have 2 protons and 2 neutrons in it. Now the total charge present in the alpha particle, according to the quantization statement, it is going to be the integer multiple of E. So now here the integer multiple, that number is 2 here. So the charge present in the alpha particle is integer multiple of E. It is 2E. There's another property of charge, that is conservation of charge. What is the meaning of conservation of charge? Let's try to get the feeling for it. What is the meaning of conservation of charge? It says charge can neither be created nor be destroyed, but you can transfer charge from one body to other body. Same definition as that you have in your first year, the conservation of energy. So the charges, you can't just create charge, okay? The charge will come from the bodies only. The charge which is already present in some body, you are just taking the charge of that body and giving the charge to the other body. It is not like with some experiment or with some mechanism or with some phenomena you can create charges. Whatever charge is present in this universe is constant. And here, if you have a system, in that system, an isolated system, and if you have some charges in that system, the charge present in an isolated system will remain constant. So this is called the conservation of charge. Now let's do a problem based on conservation of charge. You'll get the feeling for conservation of charge. So the question is, I have an isolated system. Now in the system I have three particles. One is having 3 coulomb, the other is having -2 coulomb, and the third particle, the third body is having 4 coulomb charge. Okay, now what I'm doing is, this system I'm shaking it a little bit. Because of the shaking, the particles, the bodies inside the isolated system will collide with each other, and there will be some transformation of charges from one body to the other body. Now after the process of shaking, I have the system. The first particle, initially it was having 3 coulomb. Now the first particle is having, the first body is having, let it be 4 coulomb. And the second body, initially it was having -2 coulomb, now it is having 1 coulomb charge. And the third body, initially it was having 4 coulomb, now you have to find out how much will be the charge on the third body after shaking. So by using the conservation of charge, we can find out what conservation of charge states. Conservation of charge states that the total charge present in an isolated system will remain constant. So this is the isolated system. Okay, so initially it was having charge Q1 plus the charge of the next body Q2 plus charge of the third body Q3 should be equal to the charge of these bodies. The charge on the first body, I'm calling it as Q1 prime, and the charge of the next body, the second body, I'm calling it as Q2 prime, and the charge on the third body, I'm calling it as Q3 prime. Okay, now the total charge, the initial charge will be equal to the final charge. Why? Because the system is an isolated system. The total charge remains same. That's why you can write the charges initials are equal to the charges final. Now Q1, how much it is? 3 coulomb. Now second charge, -2 coulomb. The third charge plus 4 coulomb will be equal to the first charge 4 coulomb, the second body charge 1 coulomb, and the third body charge that you don't know, and we will find the charge on that third body. So this is how you can find the charge on this body. Okay, how much it is? 2, 4, 7. 7 minus 2, it will be 5 coulombs, is equals to 2 plus 1, 5 coulombs plus Q3 prime. So Q3 prime is having 0 charge with it. How come? Now this is the mathematical way of finding the charge. Now by common sense you can say that, you see how much the total charge is, how much here? 3 coulomb, 4 coulomb, 7 coulomb. 7 minus 2, 5 coulomb. The total charge is 5 coulomb here. And here 4 plus 1, already the 5 coulomb is over now. So there is nothing left for the third body. So that's why the charge of the third body is 0. This is how you will use conservation of charge. So you will be having problems based on this conservation of charge, quantization of charge. So based on today's lecture, I will be giving you some problems. You have to solve them, and if you are unable to solve any of the problem, let me know in the comments below. I will make a separate video for those problems. So that's it for today. In the next class, we'll be studying some more phenomena, some more stuffs about electric charges and field. In the next class, we will be studying about Coulomb's law. Okay, so till then, stay tuned, stay safe. Thank you so much for watching.